ever look up at the moon and notice something strange about it? Every single night we see the exact same face. Night after night, the features never change. It almost seems like the moon does not spin at all. But here's the strange part. Spacecraft hitting the moon crash with explosive force. Even though the moon's gravity is only 1/6 of Earth's, how can such weak gravity cause such violent impacts? The answer changes how you see the moon forever. Let us break the whole thing down step by step. First, the wrong assumption people usually make. We assume the moon simply does not rotate. If it never turned, we would always see one side. That part of the guess is actually correct. But the reason behind it is completely wrong. The moon is actually spinning, and quite actively too. And gentle gravity does not mean gentle landings. On Earth, air resistance and parachutes cushion our falls, so we expect a weak gravity world to feel soft. The moon shatters that friendly assumption entirely. Now let us talk about what the moon is really doing. The moon actively rotates on its own axis. A rotation is simply a spin, like a top. Earth also rotates once every 24 hours. The moon rotates too, but much slower. It takes the moon about 27 days to spin once. It also takes 27 days to orbit Earth. These two numbers match exactly. This perfect match is called tidal locking. Tidal locking means rotation time equals orbit time. Imagine holding hands with a friend. Now spin around in a slow circle together. Your friend always sees the same face. Even though your body is turning in a full circle, you rotate at the same speed you orbit. That is exactly what the moon does with Earth. But how did the moon become locked this way? The answer involves gravity and billions of years. Earth's gravity pulls stronger on the near side of the moon and weaker on the far side of the moon. This difference in pull is called a gravitational gradient. A gradient means a value that changes across distance. Long ago, the moon orbited much closer to Earth. Earth's gravity stretched the moon slightly out of shape. The moon became a bit longer toward Earth. This stretching created two bulges on the moon. One bulge pointed at Earth, one pointed away. Now here's the key part of the story. As the moon rotated, these bulges had to move with it, but Earth's gravity kept pulling them back into line. This constant tugging created friction inside the moon. Friction is a force that resists motion. Like rubbing your hands together creates heat. The internal friction acted like a brake on the spin. Over billions of years, the spin slowed down. Eventually, rotation matched the orbit exactly, and that is why we always see the same face. Now let us talk about the moon's gravity. Gravity is the force that pulls objects toward each other. The strength of gravity depends on two things. First, the mass of the object, how much stuff it has. More mass means stronger gravity. Second, the distance from the center of the object. Farther away means weaker gravity. There is a simple formula for surface gravity. G is just a constant number, a fixed value in nature. M is the mass of the celestial body. And r is the radius, the distance to the surface. Notice the radius is squared in the formula. That means distance has a powerful effect on gravity. Doubling the distance makes gravity 4 times weaker. The moon has only about 1% of Earth's mass, so its surface gravity is much weaker than Earth's. Surface gravity on the moon is about 1/6 of Earth's. If you weigh 100 pounds on Earth, you would weigh about 16 pounds on the moon. In metric units, that value is 1.62. Meters per second squared is just acceleration. It means velocity changes by that much each second. This weak gravity feels gentle and friendly. But the moon hides a dangerous secret. The moon has almost no atmosphere at all. An atmosphere is a layer of gas surrounding a body. Earth is wrapped in a thick blanket of air. The moon has only a thin, almost vacuum layer. Vacuum means nearly empty space with no air. This absence of air changes everything about falling. On Earth, falling objects meet air resistance. Air resistance pushes back against moving objects. It acts like a cushion slowing you down. Skydivers rely on this to land safely. Parachutes use air to slow falling payloads. On the moon, none of this exists at all. There is no air to push against at all. Falling objects accelerate the entire way down. Speed alone does not tell the whole story. Faster moving objects carry more energy. This energy of motion is called kinetic energy. Kinetic just means related to motion. The formula is EK equals 1/2 mv squared. M is the mass of the moving object. V is the velocity, the speed, and direction. Notice that velocity is squared in the formula. Doubling the speed quadruples the energy. This makes impacts far more violent than expected. Space rocks fall toward the moon for a long time. They reach enormous speeds, kilometers per second. On Earth, most space rocks burn up in the atmosphere. The atmosphere acts as a protective shield. The moon has no such protective shield. Rocks arrive at full speed and hit the surface. All that kinetic energy transfers instantly to the ground. The moon's surface is called regolith. Regolith is a layer of broken rock and dust. The energy blasts rock outward in all directions. This creates a shock wave, a ripple of energy. A bowl-shaped depression forms at the impact site. This bowl is called an impact crater. The moon's surface is covered in millions of craters. Imagine throwing a heavy bowling ball into sand. So how do engineers land softly on the moon? They cannot use parachutes. There is no air. They cannot glide either. Wings need air for lift. Lift is an upward force created by moving air. So engineers must use rockets to slow down. Rockets work in a vacuum by expelling gas backward. The expelled gas pushes the rocket forward. This is called an action-reaction pair. To slow down, rockets fire downward at the surface. This technique is called retrograde thrust. Retrograde means going opposite to the direction of travel. Engineers calculate the exact thrust needed. They use the value 1.62 meters per second squared. This value times the mass gives the gravitational force. The rocket must produce more thrust than this force. Engineers use this to time the rocket burns. The rocket bleeds off kinetic energy as it descends. Bleeding off means gradually reducing the speed. The lander reaches a velocity of 0 just above the surface. Then it touches down gently without making a crater. So let us recap the mechanics of the moon. The moon does spin, but it is tidally locked to Earth. Its rotation period matches its orbital period exactly. The moon's gravity is 1/6 of Earth's gravity, but it has no atmosphere to slow falling objects. So impacts happen at full kinetic energy. This is why the moon is covered in craters. Engineers land safely using retrograde rocket thrust. Now you understand the mechanics behind the moon. From tidal locking to controlled landings, it is all physics. Thank you for watching this video. Let me know in the comments if you liked it. Don't forget to like and subscribe for more.